This conference will now be recorded.
So the artificial neural networks corresponding documents and files I have sent yesterday. So in the yesterday's folder, you will find that another folder called ANN, in which you will find the respective files. And in your canvas, you will find there is another module that has been uploaded today, and in that module you will find the KNN file. So in the canvas, if you go, uh, so I think it will be module 8. Just check. Yes, it is in module 8. Under module 8, you will find the files. So you can download these KNN files, which we'll discuss today first, and then we will go ahead and discuss the rest. So yeah. So the topic that we will be going to discuss first is called K nearest neighbor. So I have borrowed this particular PPT from Professor Ogla Wetzler, and that is there in your uh, in your the link has been given in your this thing as well. Yeah, so the link has been given in your canvas as well, and this is basically starting of machine learning. So slowly, one by one, we will go a little bit of depth, but KNN algorithm is one of the very basic algorithm that we use in machine learning. So KNN classifier, so we call it classifier. What is a classifier? A classifier is something which classifies. And what is the classification job? A classification job is breaking. Uh, so somebody probably has told you what is classification and what is regression. Classification is when your y variable is categorical. When your y variable, the one that you are trying to predict, is categorical, at that moment we do classification. So so KNN is one of the easiest classifier on earth, and we will focus on that, and we will not do the MATLAB implementation. We will do the R implementation because we're learning it in R. But you have to understand that any language is good enough as long as it is open source. MATLAB is very robust, but MATLAB is not open source. So what is K nearest neighbor? So what we do is this K nearest neighbor, this particular algorithm, how it works is that it classifies an unknown example with the most common class among K closest examples. So let's say in this particular picture, if you see, uh, various fishes are basically categorized based on their length and based on their lightness, how light they are. And so they have collected probably 1, 2, 1, 2, 3, 4, 5, 6, 7. So they have collected 7 sea bass, and similarly they have collected 7 salmons. And then out of these 7 sea bass is one kind of fish, salmon is another kind of fish. They have measured the length of those fishes and also the lightness, how what is their weight of their feet of these fishes. And in this XY plane, then they have plotted that okay, at this there is one sea bass which is here, there is another sea bass which is here. So they have just plotted the C buses in this XY plane. Now, if you have multiple characteristics, then there will be multi-dimensional plotting. This is a two-dimensional plotting which can be visible and understood, because we human beings cannot perceive anything which is higher than 3 dimension. So up to 2 dimension we can see this. Up to 3 dimension also probably I would have created another dimension here, and I would have told them that is a height, and I could have perceived that as well. So up to 3 dimension you can see that in this picture, but after that it will not be perceived. But anyway, they have drawn this in these 2 dimensions. Then what they did, so then if you have a new fish, let's say there is a new fish that has come up in the market, and you do not know whether it is a sea bass or whether this fish is a salmon fish. You do not know that. So what you will do, you will also find out the length and the lightness, or basically the weight of this fish, the length and the lightness of this fish, and then you plot it somewhere. So this is why you plot fish in this XY plane. And then you find out the k closest example. So which examples are closest to this guy? So you decide that k is equal to 3. Let's say you decide k is equal to 3. So if k is equal to 3, then there are 2 sea bass and 1 salmon, which is closest to this guy. Other are not the closest 3. So based on that, if there are 2 sea bass and 1 salmon, whatever is the mode, you classify it as that. So you classify it as sea bass. So the central tendency of the closest 3 items or closest 3 examples is something that you consider as the contributing factor, and based on that you find out the mode of those closest 3 items, and whichever is the mode, whatever is the mode, you basically tell that is your prediction. So that is k nearest neighbor, which is one of the very basic way. So if I proceed, there can be multiple classes also. So in the previous example, I told that there are 2 classes, but there can be multiple classes as well. For example, there can be salmon, sea bass, and eel. There can be 3 different types of the same thing, but there can be 3 different types of fishes. And when you are here and you decide that, okay, I will choose k is equal to 5. I will choose k is equal to 5 as written here. K is equal to 5. So when a k is equal to 5, by chance I have chosen, then there is 1 sea bass, 2 sea bass, 3 sea bass, and then 1 eel and 1 salmon comes up. So basically 3 sea bass, 1 eel, 1 salmon. Again, I classify it as a sea bass. Why? Because I am using the mode to classify. Using the mode to classify. So irrespective of if it is a binary class or multiple class, KNN can be used. KNN can be used. You remember, have you heard about any other algorithm which can be used for category, which can be used for classification? What other algorithm have you heard about classification? Yes, logistic regression you can use to do classification. That has been taught to you guys. Anything else other than logistic regression? Have you learned anything? Neural network can be used, but we have not learned it yet. Naive is also doing classification. The one that we learned yesterday was also doing classification only. Spam, not spam, is a classification problem. They could have done it like, let's say we generally use knife base sometimes to do sentiment mining, like positive, neutral, negative. So that is also classification and multi-class classification. Similarly, KNN can also do multi-class classification. Logistic regression can also do, but we have learned binary. We have not learned the multi-class logistic regression. We have only learned the binary logistic regression. And here, this one can do multi-class. Very easily, it can do multi-class logistic regression. Sorry, multi-class classification. So now the question, there are lots of question comes in when I say that. Saying this is very easy, but when I say that, there are quite a few questions that comes up. The first question is that how to decide this K, means whether I will take 3 nearest neighbor or 5 nearest neighbor or 7 nearest neighbor, because understand, if I increase the nearest number of neighbors, then it will change. For example, if I just consider let's say 3 nearest neighbor, then these 3 might be the guys, and then probably the answer will be C bus. If I consider 5, are the guys. These 5s are the guys. And I also consider C bus. But if I consider, let's say, around 10, then there is a problem. So you will see that after these 5, which are in this color, which are the next? Probably this 1, 2, 3, 4, 5. Not probably this one also. So probably these guys will come together. I'm just assuming. So when I consider these people together also, there are lots of salmon. This salmon, this salmon, this salmon, this salmon. So there will be 4 salmons in this case, or 5. There is one I missed here. So 5 salmon in this case. If I consider K is equal to 10, there will be 5 salmon and will be 4 sea bass and probably 1 eel. All I'm trying to say is that in that case, I will choose it as salmon. So what happens is, as you change K, as you change the number of K, forget about K is equal to 10. If by chance, just assume this case, that there are by chance 1 extra eel, which is very far, but 1 extra eel. 1 eel is sitting here. Okay. There is 1 eel who is sitting here, which is far away. But you take K is equal to 50. We take K is equal to 50, then we will consider all of them. And the count of eel will be 8. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, and 8. So all of a sudden, count of eel becomes 8. Though this guy is very away, you will say that, okay, eel is the number is eel. Means this particular thing is eel. Though eels are very away from each other. So basically, you have to decide this K carefully. Decide this K carefully. Okay, so there are 2 questions. How do we decide where we take the origin measure? Origin is 0, 0, no? Length is 0, so it's up to you. Doesn't matter. It doesn't matter. Origin doesn't matter. We are measuring distance from this point to this point. Why will I care about origin when I'm measuring the distance between this point and this point? Now, for this person, I have this, as Sancheta told. Okay, so I have measured it. I have measured. So what is my x-axis? If you understand this thing, that not x-axis, what are my x variables? So my x variables are, I have 2 x variables, x1 and x2, and these variables are length and lightness. And my y variable is the type of fish Now a new fish comes up and I do not know the type of fish, but I can measure its length, I can measure its weight. So if I can measure its length and weight, then I can, based on this, then I know what this position of this guy is, and then I can measure the distances. So this particular two data will be given for your training data also and your testing data also. This will be given for your training data and you have to predict for your testing data. Okay. So as I told that it is a very important decision how to decide what will be your K. So how many neighbors? So in theory, if infinite number of samples available, the larger is K, the better is your classification. That is theoretical, but that has huge problem. But the caveat is that all K neighbors have to be close. Means if the K neighbors are very scattered away, as I shown the example just now, then there is a problem. Possible when infinite number of samples available, and impossible in practice because the number of samples is basically finite. So ideally, the bigger the K, the better. But how bigger? That is something is a question. So thumb rule says that you have to check up to square root of n, where n is the sample size. N is the number of examples, means the sample number of samples. So it's a thumb rule that your K, the maximum K should be the square root of n. So if you have 100 observations, up to 10. If you have 1,000 observations, then 10 root 10 or something like that. So up to around 30. So that is a thumb rule, but not always we do that. For example, why we try to do that? Because if K is equal to 1, it often used for efficiency but can be sensitive to noise. For example, let's say this particular guy, they are predominantly reds are together and blues are together. But there is one noise who is residing here. Predominantly reds are together, blues are together, but there is one noise who is the noisy sample who is residing in between the reds. Now that noisy sample can create problem when n is equal to 1. But when when k is equal to 1. But k is equal to 3, that noisy guy will not create problem, because in this case you see the black dot will be classified as red dot, because there are two red dots close by and only one blue box close by. But when I k is equal to 1, this will be classified as blue because there is only one blue box is close by. So the chances of misclassification with a noisy sample goes up when k is equal to 1. Chances of misclassification goes down when k is large. So that's why, to reduce the chance of misclassification, so that to reduce the probability of misclassify, we generally go for larger size of k. Larger means how much? Up to square root of n. We generally go for that much size of k. But there is a penalty for that. If you increase the size of k, there is a penalty for that. So what is the difference? Both are blue when equal to 1. No. So that they have given the region. See, I am talking about the black point. How will you classify that the black point? In the first case, the black point is classified as blue because there is only one blue which is close by. So you see it is told here that it is misclassified as blue class. And in the third, it is correctly classified as red class. Okay. Yes, second one is k is equal to 3. That's why the name is KNN. That's why the name is KNN. So KNN means K nearest neighbor, and K stands for how much you take K. So that when you take K is equal to 3, it is 3NN. When you take K is equal to 1, it is 1NN. Fair enough? So what did we learn till now? We learned till now that K should be big. But there is a problem with that as well. So when you make K too larger, this particular picture will help you understand that there are, let's say, 3 regions. Okay. So larger K may improve the performance, but too large K destroys the locality. So oftentimes we see that in our test data, if we try to plot it like this, if we have never plotted it till now. So if you plot it like this, you will see that things are closely located, like blues are together and then greens are together and reds are together. So if you increase the size of K from 1NN to 5NN to 20NN, the prediction, the above one is the actual case and the below one is the predicted case. So the prediction region creates some problem. So this is the actual, this is predicted. So here this is more or less, here this is more or less matching. But here, when you take n is equal to 20, k is equal to 20, it has been simulated and seen that this matching is not happening properly. So too high k creates a problem. It has been simulated and seen. You can also try, you will also see that. Okay. And then another important factor is that you have to understand that there is a penalty for the calculation also. So I will go to just 1 minute. Yeah. So there is a problem with the calculation also when we do KNN. You have to understand that I have to measure what I'm trying to do. I have to find out the K nearest neighbor. I have to find out who are my K nearest neighbor. So here, if I plot some points, and this is my actual point from which I will be. So to find out 10 nearest neighbor, how many distance has to be calculated? So basically, sorry, 10 is too high because there are only 9 neighbors are there. So let's say I say 5 nearest neighbor. If I have to find out the 5 nearest neighbor, how many? Minimum 5, maximum 9, because I have to find out basically all the 9 and find out which 5 is closest to me. I have to find out all the 9 and then I have to find out which 5 is closest to me. So as the k increases, the number of neighbors increases and the number of calculation also increases, which creates a huge problem. And to solve this problem, we have to make sure that we take k in such a way, such that the calculation complexity does not happen. This overfitting basically does not happen. And but still it is not so low, that noise can create a problem. So this is a arts basically. There is no science involved in this one. This is a arts. This is a, I would say, a trial and error method. So we start with k is equal to 1, go up to k is equal to square root of the sample size, and we try to see at which k the prediction in our validation data set or in our testing data set is coming best. That k we choose. It's a trial and error. So first we choose with k is equal to 1 and see what is the error rate. Then we do it with k is equal to 2, and then we do it with k is equal to 3. Up to k is equal to square root of n, we go on trying this. So this is something that we try to do in a KNN algorithm. So this part I will not go into the details. This is very technical part where it is saying that it converges to the best possible result when the sample size is pretty big. So big sample size is something that we like. But again, for KNN, as I was telling, just this much you understand that if the sample size, that means the number of n, if the number of n is high, that helps KNN to work better. If we have lots of sample, if the number of n is high, that helps KNN to do good prediction. But as I just shown at the back, if number of n is high, that will also bring in computational complexity. So that will also increase the complexity of computation. So basically number of variables into 10, like regression. Number of variables into 10. It's a thumb rule. Okay. So in the previous case, like I have length and lightness, so ideally 20. So sample size high, it is good, but sample size high will also create complexity. So how to handle that then? So there are certain ways to handle that, certain algorithms to handle that. So these are part of the algorithm. These are already coded. What is this number into 10? Number of variables, number of x variables. So if you remember length and lightness, so x number of x variables are 2. So I need 2 into 10, that is 20 sample size. Okay, very good. So there are certain techniques that are there in the algorithm. The algorithm we will not write. We will use a library, but you should know for interview purpose, for your own purpose, you should know that how people actually solve this. That is the minimum. That is the minimum. That is the minimum suggested. So what we try to do is we try to create a decision boundary. As I told that there are the blues and the greens generally, or similar kinds of people generally flock together. It has been seen in data science that they generally flock together. So what we try to create is we try to create this kind of a decision boundary, that whenever my observation is in the left side of the boundary, I will make it blue. Whenever it is in the right side of the boundary, we will make it green. So how can I do this? How can I change the decision boundary? So let me show you that. So what we do here in this context is just one. What we do here in this context is this one. So we try to find out within this decision boundary, is there is one observation such, let's say this one. if you can see that this one, which is where the arrow is made, you can see that all the nearest neighbor of this guy are red. All the nearest neighbor of this particular person is red. This particular person is red. So if all the nearest neighbors of this particular person is red, there is no point on finding out the distance of these two people, because this person will not actually contribute to anybody's misclassification or classification, because he is not near to any green people. So let's say who are the, so let's say if a particular point is here, if a new observation comes here, will this guy contribute to that guy? Probably no, because you will have lots of people here. This person will not contribute towards this particular person's classification. If a value is here and if k is reasonable, will it contribute? Probably yes, probably no. I don't know. If a value is here, will it contribute? Probably no, it's pretty far away. So all these people who are near to the boundary, generally they contribute towards the classification or misclassification. All those guys who are in the middle generally does not contribute to anything. So while calculating the distance, we generally do not consider this middle one. Obviously, that can bring in some level of noise, some level of misclassification, but that will also bring in a lot of advantage in terms of the calculation speed. You have to understand that when we do prediction, we cannot wait till the late, means we cannot wait for 5 hours, 6 hours to do all the calculation. And if the data size is of, let's say, 1 million customers, if I have 1 million customer data and a new customer comes in and I try to decide that whether this guy will buy or not buy, my y variable is whether the new customer will buy my product or not buy my product. And I have a past data of 1 million customers. I cannot find out the distance of this particular person with 1 million customers, because that calculation will go on for hours and I have to take a decision very quickly, because you have come to my app, you will hardly stay in my app for two minutes, not even that. So within that 2 minutes I have to send you whatever advertisement, this, that, blah blah blah, so that I can make you buy. So oftentimes prediction is instantaneous. You need instantaneous predictions. So then you cannot spend time. And if you cannot spend time, then you cannot waste time in computation. And if you cannot waste time in computation, all those samples which does not change the boundary, as I told that the boundary matters. So all those samples which does not change the boundary, whether this guy is there or not, this boundary does not get affected. This boundary remains. So all those guys who does not affect the boundary, we generally do not consider that. That is one step of reducing complexity. Applicable where? Applicable in 1NN. So this is how we actually use 1NN or lower size NN, basically lower size NN, but still can do pretty good job. So 1NN or lower size NN, but still we can do pretty good job in terms of the calculation by ensuring that the middle values, the values which are in the middle, which is not contributing towards the boundary, gets vanished from the data set while doing the calculation. They do not get vanished, but during the calculation we vanish them. That is one way. Also, another way is we do not calculate the distance up to the last point. So let me give you an understanding what I'm trying to say here. So to understand this particular point, partial distance, we have to first understand that how distance is measured. How exactly distance is measured. So the distance in this condition is, distance is measured basically by using this kind of a formula. this formula, which is called a Euclidean distance formula. Okay, what is Euclidean distance? Have you heard about this thing, Euclidean distance? So let's say this is my x1 axis. Sorry, this is my x-axis and this is my y-axis. This is my x-axis, this is my y-axis. This value is 2. This point, yes, that's the straight line distance, 2, 2. And this point is 5, 3. The question is, what is the distance between these two lines? The distance between these two lines, if it is A and it is B, the length of the straight line AB is written as square root of 5 minus 2 square plus 3 minus 2 square. Or in other words, x1 minus x2 square plus y1 minus y2 square. That is how the distance is measured. This is called Euclidean distance. Fair enough. Now this is when I have lightness and length, and the observations are like 5, 3 and 2 and 2. This is the case. The example that I have just shown, that is the case like that. Let's say I also have another variable, not 2-dimensional. I have 3-dimensional. Let's say lightness, length, and let's say speed. In what speed they run. So that is, let's say, 4 and 5. So then the distance between this point A and this point B in a 3-dimensional space will be, in a 3-dimensional space, the distance will be 5 minus 2 square plus 3 minus 2 square plus 4 minus 5 square. Okay. Or in other words, x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. That is how we measure the distance between two objects A and B. Are you with me up to this point? Are you with me how to measure the distance? Okay, now I will bring in a little bit of complexity. Okay. Now remember, understand, yes, we can go to infinite parameters. We can go up to infinite parameters. No, this thing. Okay, Tarundeep. Now the next question that comes up here, let's say this lightness, or if I forget about fish, we were talking too much about fish, though I'm not wrong. Anyways, so let's say this is your 2 persons and this is their monthly income, or let's say yearly income in lakhs per annum. Income in lakhs per annum. This is their number of siblings, and this is their family income. Okay, again in lakhs per annum. Oh, this cannot happen. Sorry, because 5 income of this person. So let's assume this is 7. So then 7 minus 5 square. Okay, are you with me? Are you guys with me at this point? Let's just change the. Okay, fair enough. Now, instead of lakhs per annum, by chance if I measured it in K per annum, then these would have been 500 and 200. Is it not? If by chance instead of lakhs per annum, if the variable changed to K per annum, this value would have been 500 and 200. And this would have been 500 and 200. So all of a sudden, whenever A and B was very close, they becomes very far away. Yes, so that's what I'm coming to, Tarundeep. That before we do all of these things, before I find out the distances, we have to normalize. Otherwise, the dimensions of the values will have an impact. Yes. Pritam, yes, it does. And I am trying to tell how that complexity can be reduced. I'm trying to tell how that complexity can be reduced. It does, absolutely it does. So as Tarundeep told that before, because there is a dimensionality issue, because if I change the dimension, the values becomes very high or very low. I have to, before I do any distance calculation, I have to normalize them. I have to normalize them. Yes, simply speaking, normalize means to get all units to equal scale 1, and there is no dimension will be there. Not only equal scale, there will not be two dimensions. So there is two way of normalizing. Let's say one way of normalizing is that your new x, whatever is your variable, the new x is x minus minimum of x divided by max of x minus minimum of x. This is called min-max normalization. Min-max normalization. And another is the new x is nothing but x minus mean of x divided by the standard deviation of x. This is called basically standardization. Any one of them you can try to do. The first one makes the x-axis, whatever variable it is, it actually keeps it between 0 and 1. It holds it in between 0 and 1. And the second one is basically change it to their z value. Their standard normal value. If you remember, their z value, if they that is what they convert it to them. So x minus min x by standard deviation x. So which one is better? Generally, in case of econometrics, we use the second one. In case of machine learning, we use the first one. Generally, but there is nothing to say that which one is better, which one is worse. Machine learning is generally not affected by outliers. That's why min-max will work. Econometric techniques like regression techniques are affected by outliers. That's why and standardization makes sure that outliers can be removed. That's why we use the standardization technique to create this thing. So first objective is to normalize. After you normalize, you can use Euclidean technique to find out the distance. Before normalizing, you cannot do. Fair enough? Are you with me? So you have to normalize your variables before you can go ahead. Is it okay? Okay. Now, still our problem is not solved. Yes. No. So we normalize everybody. We normalize all the variables, all the independent variables. But still our problem is not solved. Let's say now there is A and B. And this is his own income. This is his family income. And this is his number of siblings. And after normalization, let's say this is what we got. Number of siblings is also normalized now. That's why it's point. Otherwise, I don't think anybody can have 0.3 number of siblings. And this value now can be lower than this because this 0.4 has no relationship with this income. This 0.4 has relationship with the highest income among all the observations. Highest family income among the observations. So though at the top the family income has to be higher than the individual income, here after normalization that might not happen. So these are some of the basic things that we have to understand, that after normalization that might not happen. So how 0.3 is less than 1? Is it a question?
Sir, yes, sir, it is a question. You said that number of siblings is 0.3 and 0.2. So how we will make a consideration? Because we can consider a sibling either 1, 2, 3 like that. So means how we are counting or something, sir?
Let's say I have 10 people's data.
Okay.
These are the number of siblings.
Yes, sir.
So my father's generation, so 5 siblings is possible. Okay. So this is the number of siblings. Now I want to normalize it. So what will be the normalized value of this? This will be 2 minus 0 divided by 6 minus 0.
Yes, sir.
Minimum of this is 0. Maximum of this is 6. So that's why 2 minus 0. If I do min max, this one, if I do this one, the first type of normalization. So x minus minimum of x divided by maximum of x minus minimum of x. So 2 minus 0 divided by 6 minus 0 comes up to be 0.33. This is not the number of siblings. This is the normalized value of the normal of siblings.
Got it, sir.
Got it? Okay.
Yes, sir. Thank you, sir.
So let's say these are the values that I got. Okay. And the y that I'm trying to predict, by chance, let's say, the y variable that I'm trying to predict is that whether you will get a promotion or not. I'm trying to predict whether you will get a promotion or not. Now tell me, out of these 3 variables, which variable should have higher contribution on your promotion behavior or promotion probabilities? out of the three variables, your own income, your family income, and your number of siblings, which one has a higher probability of having a promotion? Own income, right? So as your income increases, your chance of getting a promotion comes down, because generally it's a what we call pyramid. More number of seats are there at the bottom, less number of seats are there at the top. There can be only one CEO. So as you go up the ladder, the chance of further promotion in a year or in 2 years or 3 years goes down. So, but siblings and family income has no contribution on that. Then why will I give equal weightage to all of these three things when I'm trying to measure A and B? Now you will say that why don't we just give zero weightage? We can just forget about these things because these have no impact. Let me tell you that okay, this is not number of siblings. This is not number of siblings either. This is your, let's say, performance, and this is your years of experience in that organization. Now all these three impacts your promotion. All these three has contribution towards your promotion. But should they have similar weightage? Should they have similar kind of effect on your promotion having behavior? Probably no. Probably this one will have W1 weightage, this one will have W2, this one will have W3. So then in that case, we measure the distance between A and B as W1 into 0.5 minus 0.2 squared by W1 plus W2 plus W3 adds up to V1. W2 into 0.3 minus 0.2 square plus W3 into 0.4 minus 0.7 square. So basically, we take a weighted average. Fair enough? Now, how the weights are assigned? Again, weights can be assigned based on your common sense. The weights can be assigned based on our simulation, that which W1, W2, W3 is. If you do not have that data, if you do not have an information, you have to keep on changing. Like you do not know K, like you do not know for which K you will get the best result. You have to also keep on W1, W2, W3. You have to find out for which values of these things you will get the best result. So you can run a loop and find out at what level it is optimizing. So that's what they do. Okay. So in these lines, this is told. So see, I skip quite a few things. First of all, this is how Euclidean distance is measured. I told about this. Then some distance, some talking about what is Euclidean. This thing has been discussed here. Go and read that. Then I told about normalization. You have to first normalize it. So this is the formula of min-max normalization. This is the formula of standardization basically. So we have already discussed about this. Then we can separate discriminative features and noisy features. As I told just now, I told that the noisy features are like your family income or your siblings income. So we can actually give zero weightage to them, or we can put certain weightage. This is WK, and this WK can be learned through cross validation. See, it is written here that we have to find out, can learn the weights WK using cross validation to be covered later. So basically, cross validation means it's a simulation. You try out the different WKs and try to find out which one is giving best result, which one is not. Yes. So in the procedure of this thing, we try to find out the weightages. As I told that it's a trial and error method. See, Anindo, all these are algorithms, and each of them, Anindo asked me, sorry for interruption, could you, this is the question of Anindo, I will just put it here. And all these algorithms that you are learning here are all applied in any situation. That yesterday I was giving you an example of turbines, and you were talking about, we were discussing about which turbine will have higher productivity based on the wind powers and etc. You have last 1 year's wind power data and the turbine's productivity data, and you try to find out that how the wind power impacts the productivity. That exactly same thing can be applied using this thing also. Only thing is the x1, x2, x3, x4, instead of lightness, instead of length, it becomes the wind powers. So it practically becomes, you have to, what you have to understand is all the algorithms that we are teaching here, all the algorithms can be applied in the situations that you face. It can be applied in the situation that you face, which is wind power prediction. It can be applied to a situation that some sales guy face, sales prediction, or let's say the one that I just, some of the examples that I told, let's sales prediction, or let's say performance of an employee prediction, or let's say whether you will be absent or present tomorrow, predicting that, whether you will get a promotion or not, whether your machine will fail or not, means whether there will be a breakdown in the process or not. All of these things. Yes, Sridhar, can you please? Yeah, so all of these things are basically where these things apply. Our job is to see that, to visualize that how I can apply it. And then we have to also visualize and find out that which one, if I have 5 different algorithms available, which one will I use ultimately? And how I will decide that? I gave a Babaji example in the first class, if you first or second class, that there are 5 Babajis, and I will follow that Babaji who gives me best prediction of my past. Same applies here. There are 5 models. I will follow that model which gives best prediction about my past. But before I do that, before I apply that, I have to learn the algorithm also. Now, it's your choice, Anindo, how much depth you will remember. Frankly speaking, if you want to be a data scientist, you want to have pretty good depth. If you don't want to be a data scientist, don't worry, that is not required. If you want to be a manager, you have to only know that, okay, these are the 4 or 5 algorithms available. Whenever a BTech guy comes in, who is a fresh BTech guy, very energetic, blah, 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 I will ask him that, put these 5 algorithms and give me the result. You have to talk in his language, that's all. You do not have, and whatever bullshit he comes up with, you have to understand that. He should not be able to means take you for a ride. If you are up to that level, then that's okay, that's enough. For a manager's perspective, I'm talking about. You should know who can do it and at what cost, and what has to be asked to that guy. This is the same thing that I was telling. So here also, all these algorithms can be applied in any prediction that you do, any prediction that you do. Okay, coming back to complexity reduction. Now, one complexity reduction I told that, one complexity reduction is what I told is moving the middle point. The middle point which does not contribute towards the boundary creation, remove that. We don't have to remove that. We don't have to do it manually. The algorithm, which is the package, automatically does that. But I have to know that what this package do. Otherwise, it's a black box. So that's what I'm saying. That this guy actually, to make sure the speed goes up, it removes the middle values. That is number 1. Number 2, what it does is, it does not calculate the whole thing. Let's say there are 10 features. Features means X variables. Let's say, okay, I will just go back to here. So let's say I am trying to measure the distance between A and B. And I am doing a 3NN. Okay. I am doing a 3NN. 3NN means I have to find out the closest 3. So I got this guy, which is A. And I find out the distance of A with B is 3.22. A with C is 2.88. A with D is 4.12. These 3 values I have found out. And now I am calculating the distance of A and E. Okay, these first 3 distance, A and B, A and C, A and D, I found out. A, B, C, D are 4 points. These distances I have found out as of now. And I am calculating the 4th distance from A. Okay. So if I am calculating the 4th distance from A, how will I do that? I will do it like this: x1 minus x2 square, or I would write, let's say, right, xa minus xe square plus ya minus ye square plus za minus ze square plus something something plus something something plus something something. If there are lots of variables, then I will keep on going calculating. Right? Are you with me? I have to calculate the whole thing. Now you just check. The square of this value is close to 10. The square of this value is close to 9. The square of this value is close to 16.4. This is distance square. This value is close to 10, this value is close to 9, this value is close to 16.4. Here I got xa minus xe square as 4. This one I got as 5. This one I got as 5. And this one I got as 4. Question is, after calculating up to this one, should I go and calculate further? When I reached up to this point in the distance calculation algorithm, should I further go and calculate? Because see, this is 4, this is 5, 9, this is 5, 14, and another 4, 18. Already it has become higher than k, higher than the closest 3. It is not lower than the closest 3 as this moment. So I will not go and calculate. I will stop my calculation here. I will break my calculation here. And that's how I reduce the complexity time, the calculation time. That's exactly what has been told here. So have current k closed samples and abort distance computation if partial distance is already greater than the full distance of the current k closest samples. So if the partial distance calculated is already higher than the k closest, then I will stop it. Now, obviously, complexity decreases, but it also depends on luck. How much? It depends on luck. So these are some of the basic things that we try to do to reduce the complexity of the model. So next, the implementation in MATLAB is given in this PPT. This particular PPT is already there, shared in Canvas. The link is shared. You can probably go and check the PPT in Canvas. I will go and show you the implementation of this one. So there is knn-mon and knn2.r files under knn zip file that I have shared. Please download them. Please download the files. Put it in a folder, any folder. Put it in one folder. Unzip it and put it in one folder. Okay, so Nivedita, Sonali, and Funny, are you guys here? Yes, so I have sent you a mail from Canvas. You can search in your this thing in your email ID. You can search. There probably it will go to the spam folder. There is an email that has gone from Canvas basically, which is an invitation to the course. So all the other guys have access to the files. You can register there. No, that is okay. That is okay. I know you have downloaded it. I'm not talking about that. Yes, I'm asking to create an account in Canvas, and then in the next session, when I have the next session with you guys, I will tell you where to go to find out what. So that will help you in your hands-on. Okay, so in this particular thing, what we will do is we'll load a package called library class in knn1.r file. Oh, sorry. What I'm doing here. Sorry. So first of all, check the data set. It's a classic IDs data set which we use. So if I just write view df, what is it? Just 1 minute. Yeah. So this is your IDs data set. Basically, these are various species of flowers. Okay. So the fourth one is the species of various flowers, and the first four columns are basically the sepal length, the sepal width, the petal length, and the petal width. The four values are given, and the fifth column, basically the first four columns are your x variables, and your fifth column is your y variable. And I try to predict a new flower comes up. I do not know what kind of species it is. So what I do is I measure the sepal length, sepal width, and the petal length, petal width, and then put it here to predict that what is the species of that particular flower, which is new, which is unknown. Avi, can you give an example from, let's say, petrochemical industry, what this kind of a model can apply? The same kind of data set can apply. You can unmute yourself and give an example.
This kind of thing can happen when, let's say, with number of wells and the depth of the wells to be drilled at different depth, and at what different depth you are getting oil and gas.
Yes. So what will be the y variable there?
Sorry, can you repeat yourself?
So y variable, what will be the dependent variable? Success or failure, right?
Success or failure of finding oil and gas, right?
Yes, and the x variable can be the depth, the temperature, probably this, that. So before a geologist, before they start excavation, they create an estimation that whether after excavating this, I will get a oil and gas field below my this thing or not. So
Right.
before the estimation, they want to make a prediction. Thank you, Abhi. So they will want to make a prediction, and they might probably take a sample of the land or whatever. Some sample, I don't know. Sample of, so geologists take sample of the rocks, and from that sample they measure some ABCD aspects. And when these ABCD aspects they measure, they match with other success or failure instances. And whenever they get high chances of getting success, then only they will start excavating, because excavating is hugely costly, right? So if you excavate a lot and then you get nothing, then that's a huge amount of capital investment that goes for a toss. So these are some of the examples that you can apply here. So okay, so coming back to this problem, so this is a IDs data set, which is a easy classic data set. Now this is my job to teach you easy things, so that my life is simpler, and you will face much bigger, tougher things in your life. Yes, somebody was saying something.
Sir, Madhusmita, sir, where is this iris data set actually? I got those R files, this KNR1 and 2, but how this table is coming means it was
Okay,
there
so
in assignment.
why don't you run the first two line? This is an inbuilt data set. I have not given
Okay.
the data set separately. It's an inbuilt data set. Run the
Okay.
first two lines.
Just a minute, sir.
Got it?
Yeah, got it, sir. Got it, sir.
Okay. Okay.
Got it, sir. Thank you.
Okay. So now what I will do is, as usual, what I will do, the first job I will do is I will break it in between training data and testing data. So first, see, in the last class, I took, without any discussion, I took the first 4,000 data points as training data. Yeah, sorry. So I took the first 4,000 data points as training data, and the next 1,500 are testing data. Without any discussion, I took that, which was not right. I knew that it would give good result. That's why I did it. But in real life situation, you don't do it. You do a random sampling. You randomly decide that which one I will take as my training data and which one I will take as my testing data. So how do you randomly decide that? What you do is you collect from this particular data point. Let's say here, how many data points are there? Can anybody tell me how many data points are there in this data set? 150 data points are there. Very good. So 150 data points. Out of that, you randomly choose, say 70% or 80%, 70-30 rule. I will go for 70-30 rule. So randomly choose 70% of your data set. So when you randomly choose 70% of your data set, what I am trying to do in line number 5 is creating a random number. What I will do? See, what this n-row IDs gives me, n-row ID gives me the number of rows, which is 150. Now this sample function is a random number generator function. So the idea is sample 1 to 150. So if I just do it small, let's say sample 1 to 10, 3. Just if I write this much, this will give me 3 random numbers between 1 to 10. Okay, this will give me 3 random numbers between 1 to 10. So what I would do here is basically 0.7. I will make it 0.7. So I will write it 1 to 150, comma 0.7 into 150. 0.7 into 150 comes up to be 105, right? So 105 random numbers will be generated and saved in some variable called RAM. So this is 70%, not 90%. Okay, because 70-30 we will break it. So if I run it, and then if I check the run variable, these are the random numbers generated. These are the random number generated between 1 to 150. And how many random numbers? 105 random numbers. Now what I will do with these random numbers? I will take these rows which has these numbers. I will take these rows as my training data and the rest of the rows as my testing data. Okay, so this is important. So what Tarundeep just told right now, you can check the chat box. Tarundeep told that the random number generated for me and the random numbers generated for you are different, right? Are you getting the same random numbers? Very good. So to make sure the data set, whatever I do and whatever you do comes similar, what we do is we write like this: set seed, set.seed, and then some number. Let's say I write 100. Set.seed 100. You can put any number there, 100 or 5 or 6, whatever, doesn't matter. You run this line, set seed 100, and then run this line. And then check the run. If you and me have similar kind of processor, we should get the similar numbers now. Are you getting the same number now after doing set seed 100 and then running this run? First you do set seed 100, then you sample once more, and then check what did you get. Are you getting similar or different numbers? Are these numbers similar? For some it must be similar. Still different? Okay, why don't you do one thing? Can any one of you put your number here in the chat box? Copy and paste. Any one of you. Let's say Manjari, Bindu and Abhiraj. Can you put your numbers? Yeah, see. Tarundeep, wait a minute. Wait. Enough. So check Arun Babu, Lokesh, Tarundeep, Abhiraj, and Bindu has the same number. It's not magic. It's happening because of some reason. It's not magic. Right? You got the same numbers now? You guys got the same numbers? So your processor is same. That's why. Okay, fair enough. Yes, my processor is different. I think you have an Intel processor, everybody. I have a AMD processor. It's my personal laptop. If I use the Intel processor, the result will come same. Yeah. So doesn't matter. So we generally do not only write set seed, we also say write down that which processor, which number processor, so that it is reproducible. Okay. Anyways, doesn't matter. So now what I will do, I will write a normalize function. You see, this is a function called normalize function, which will normalize the data. So the input of the function is x, and the output of the function is x minus minimum of x by maximum of x minus minimum of x. This is a function that I define. And then I apply this function on the first 4 columns, 1, 2, 3, 4. in the IDs data set, in the first 4 columns, 1, 2, 3, 4. Only in the first 4 columns, 1, 2, 3, 4, I apply this normalize function NOR and then save it in IDs norm. That means normalized IDs dataset. So I run this. Just let me show you what did I get. So now all my 4 variables are normalized. Can you see that? That all the 4 variables are normalized, means they are between 0 and 1. They are between 0 and 1. Okay. And the summary looks like this. You will see that the minimum is 0, the maximum is 1, and more or less their means are also same. 0.42, 0.44, 0.46, 145. So more or less they are balanced now. They are not disbalanced anymore. So no specific outliers, no disbalance issues are there. Now after I normalized, using that rand variable that I have created, I will create the training data and the testing data. The training data and the testing data. Okay. So iris train, if I just check the iris test, this is iris test and this is iris train. Iris train has 105 observations. There are 105 total observations here, and iris test has 45 observations. Okay. So what did I do till now? I read the data, I normalized it, I did a sampling and created a training and testing data. Remember, the y variable is not there in the training and testing data. So I have to put the y variable. So ID's target category, I should write train category, or let's say target category. ID's target category is the 5th column and only such rows where this rand variable is there. So what I basically create is the y variable of the, this is the y variable, what I created is the y variable of the training data, and this is in this line number 23, I am creating the y variable for the testing data. So this is minus rand, means what does this minus rand do? Can anybody tell me? What will this minus rand do? Yes, remove rand. That means all rows other than those rows. Include all rows other than those rows and the column number 5. So if I run that, that gives me the test category. That gives me the test category. So these are the testing category, 45 observations. The previous one had 105 observations. So I have created my training data, testing data. I have created my training category, testing category also. Now under this class library, there is a function called KNN. What is this thing? See, remember, I have taken how much? I have taken 105. So square root of 105 is 10. So I should take k is equal to 10. Fair enough. So up to 10, 11, I am okay. And my call is iris target category, and iris train is my training data, iris test is my testing data. So I run this KNN, taking k is equal to 13. It ran very fast, and then I created the confusion matrix. So if I just run the confusion matrix, you see this is a 3-dimensional confusion matrix. That means not 3-dimensional, basically 3 cells. So these diagonal elements are my correct prediction. only one misclassification. I am telling you with big words that this is a sample data. This kind of expect in your real life this much accuracy you will get. You will never get. You will get 70%, 75% accuracy in a 3-dimension when there are more than 2 categories. If you get 70-75% accuracy, you should jump like this. So you will never get this kind of an accuracy. So don't. So it's just to show in the. So just to show in the class, I have used this. So accuracy, if I want to find out exactly the accuracy percentage, the accuracy percentage is 97.778, which is pretty good. So that's how we generally run KNN. What I will do now, if you have understood it more or less, what I will do now is I will take a break of 10 minutes. Okay, got an error? So just check, you have not run this line. Arun Babu, you have not run this line number 21. Just check, because that's what it is saying. IRIS category, IRIS 10 category is not found. Anindo, for you have not run this line. Just check the error and you will understand. You have not run this line. Anindo, you have not run this line. Your RAN is not found. RAN not found means that particular variable has not been created. In your check your global environment, it is not there. You should check. Ideally, you should check from k is equal to, you should run a loop here. So if I were you, what I would have done is, I would have said that accuracy, just check the code that I'm writing. Accuracy is equal to 0. I would have written like this. Accuracy is equal to 0. Don't do this, huh? I'm just showing you later point of time. So for I in 1 to 13, for I in 1 to 13, I will calculate all of this thing. And then let's say accuracy 1 is equal to 0. So accuracy 1 I is equal to this. To understand what I have done, I have introduced a new variable. Accuracy 1 is equal to 0, some new variable. Pranamanda answering you. Accuracy 1 is equal to 0. Then I am running a loop. For I is equal to 1 to 13, that k is equal to I, and it will calculate for each of them, it will calculate the accuracy and save it here. So if I now run this loop, if I now just run this loop, what I get is accuracy 1. Which one is the highest? This is 95.5, then 93, 93, again 95.5, 97, 97. So I think I am getting pretty good accuracy even k is equal to 5. Forget about k is equal to 10, 11, 12 is obviously accurate. 10 onwards is obviously accurate. But even at k is equal to 5, I am getting pretty good result. So when I implement it further, for my analysis, for my prediction, I will use k is equal to 5. Okay, great. So I will take a 10 minutes break, but there is no break for you guys. For you guys, it is 5 minutes break. And then I will not tell you what this KNN2 is. This is another data set. The same problem has been implemented in another data set, knn2.r file. My ask will be from you guys, run it one by one on your own computer and check any one step if you are not understanding or not. You should understand the code every line one by one. So just check the code whether you are understanding. And this is currently it is 5:32, and I will come back around, let's say, 5:45, 13 minutes, 5 minutes break, and then 10 minutes you can get, 8 minutes you can get for that particular thing. 5:45 I will come back and I will start with artificial neural network. Thank you.
Hello.
Yes.
Yeah, actually, in that knn1.r file, I'm not finding. I'm not able to find that for loop that you are just presenting right now, few minutes back.
That I just wrote. I just wrote now.
Okay. Okay.
Okay. So somebody asked me that should we not go for k is equal to smaller values? We took k is equal to 13. Should we not take k is equal to smaller than equal to 10? So what I did is I ran a loop from k is equal to 1 to k is equal to 13. And for each of them, I found out the accuracy value and just shown that I can take k is equal to 5 to get a better accuracy.
Okay. Okay. Got it.
Okay, so trial and error method. Another trial and error which we didn't do now is weighted. Currently, we have taken everything to have same weight. We can put weights also in the knn function. If you see, if you go with the help of the knn function, you can also give weights there. So that is also something that we didn't do right now. When you try to implement that in your actual project, you will be putting that.
Okay. Thank you.
Okay.
Hello.
Hi. So you have to immediately you have to install this lifecycle package. Just run this one. So there will be no separate project, like the assignment 1 has been given, another 2 assignments will be given for this course. So this is for Nivedita. Okay, installed our packages lifecycle. Okay, now we will be discussing about the next one, which is artificial neural network. Let me just share the screen. So next, anyway, again call the library. Again, start from the first. I will share that. No issues. I will share that. That is still open. So you can post all this in the normal thing. Other people might be thinking what I'm saying. Okay. So what I will do here is I will be going for artificial neural network. What is artificial neural network? A neuron looks like this in our body. It's a single neuron cell. So non-numeric variables, PT, has to be converted. If you at all want to use them, has to be converted into dummy variables. 1-0 kind of variables, you have to convert them. Yes, Madhusmita, yesterday's files. Artificial neural network is there in the yesterday's file. So a single neuron cell looks like this, where there is a cell body, there is some dendrites. So this part is basically dendrites. This one. So this part is these are dendrites, and this is the cell body, and then this is the axon, which sends the information. So here the data gets inside. In the cell body, the data transformation happens, and then through this action, the data goes to the next cell, and there is another cell here, which again has some dendrites and an axon. So here this guy also collect the data, again transform a little bit, and then pass it on through its axon. So that's how the neuron works in our body. So what happens here when we pass the information, this is basically what happens. So let's say there are 3 variables, x1, x2 and x3. So each of these data that is generated, x1, x2 and x3, gets different weightages depending on which neuron it is attacking. Let me give an example. Let me give a common example. So when you see a let's say you have seen a rasgulla. Okay, you have seen a rasgulla. This is your eye. This is the rasgulla. So what are the various characteristics the rasgulla has? It has a color. It has a shape. It has a texture. It has a taste. Right? Probably some other characteristics also is available. Now, when you see, it has a smell. Okay. When you see that neurons in this particular thing will give some weightage here, some weightage here, some weightage to this one, but probably zero weightage to this two, because our eye cannot check taste and smell. This is my eye's response. When I touch it, I cannot see color. I can get some weightage of shape. I can get some weightage of texture. I cannot get taste. I cannot get smell. When I taste it, I don't know color. Probably I have very little idea about the shape. I have some idea about the texture. I have some idea about the taste, pretty good idea about the taste, and no smell. So all I'm trying to say here that depending on which organ, which neuron, these 5 characteristics will get different weightages. The weightages are different. Some of them are zero weightage, some of them are some weightage, and those weightages are different. When you put a rasgulla on your tongue or in front of your eye or on your hand. So that is exactly what this ANN also does. Let's say I have X1, X2, and X3, 3 different attributes. All of them get some weightages, W1, W2, W3. So here what it's getting generated, Wi into Xi gets generated in the axon. And then there is a function which transforms it a little bit. And what does it pass? It passes on this value to the next neuron. So this exactly is a job of a single neuron. And this is there in our whole body. Actually, all the statistics and algorithms are basically got their, they have basically got their, I would say, inspirations from the nature. All algorithms have got their inspiration from the natures. Artificial network, neural network has got, like genetic algorithm got inspiration from genetics, from evolution. Artificial neural network gets inspiration from our neural network process, the neural system that we have. From where can we get these weights? Can we take this from LR? Wait, that is what we are going to do. Wait, Tarundeep, I will answer that. Okay, be with me. So it gives some weights and then it transforms and passes it on. Now, what are the various kinds of transformation can happen? These are the various kinds of transformation can happen. So each of these is one kind of activation function. The most common activation function is this sigmoid function. The most common activation function is this sigmoid function or this linear function. Basically, fx is equal to e to the power x by 1 plus e to the power x, or fx is equal to x. These are the most common activation functions that we have in our world. Okay. Now, which one we should use? Again, it's a trial and testing method, but these are the most common that we generally use. The neural network, the whole network, the one that I have just told you, is only one neuron. But the neural network can be of different type. There can be of different shape. So what happens is, even if our body, if you check, let's say this is my hand. This is me. And this is my hand. Okay. And there is some object here. There is a neuron on my hand which collects the information about this box, the texture, the weight, whatever, and transform it to the next neuron. Next neuron collects here and transform it to the further another one neuron. The next neuron collects here and again transforms. Again another neuron collects here and transforms. Another neuron collects here and transforms. And then it goes on till it reaches my head so that I understand. Now, each of these neurons that I am trying to say, let's say this one that I told here, which is located here, not only getting information from one single neuron, it is also getting information from this, it is also getting information from this, it is also getting information from this. Probably, let's say this neuron is getting information from somewhere here. This neuron is getting information from some people here. This neuron is getting information from some people here. So everybody is getting information from some other neurons which are nearby. Now, what happens is, in a normal condition, we have absolutely no idea how many neurons are there. There are millions of neurons between your hand and your head. So these are all called hidden layers. And this is basically your primer layer, the first layer, which directly gets connected with the object, the stimuli. And this is your terminal layer, basically your head or spinal cord, which is the terminal layer. So the same applies here. Let's say I have x1, x2, x3, some three variables. There will be some hidden layer, and then there will be a terminal layer. So this is node 1, node 2, node 3, node 4. This is basically layer 1. This is basically layer 2. And this is your terminal node. And this affects this node. This guys also affects this node. Then N1 affects N3 and N4. N2 also affects N3 and N4. Then N3 and N4 gives the idea to the terminal node. This gives me the information out. So this is a structure of a neural network. Now, I know how many Y variables. So how many terminal node is there? I know before I implement a neural network. How many X variables are there? That also I know before I implement a neural network. But how many hidden layers will be there? And in each layer, how many nodes will be there? I have no idea. And it is a trial and error method. Like in the previous example I told, what should be your K is a trial and test method. Similarly here, how many hidden layers are there and how many nodes are there in that hidden layer? There is no specific rule for that. It's a trial and error method. But still it has been told, it has been seen empirically. Still it has been seen empirically that up to 3 layers and up to 3 nodes in each layer works well for all practical purpose. For all practical purpose that we generally will face, up to 3 layers and up to 3 nodes in each layer is good enough. Up to 3 layers and up to 3 nodes in each layer is enough. So how does the algorithm work? Let's talk about that. So I have given lots of examples about its similarity with our neural system. Let's talk about how does it work. So what happens is, let's say the previous example. Let's say I have x1, x2 and x3. x1 is your income, x2 is your performance, and x3 is your years of experience in this organization. And your y is whether you will get a promotion or not. Okay, your y is whether you will get a promotion or not. And you decide that there will be 2 layers, node 1 1, node 1 2, and node 2 1 and node 2 2. x1, x2 and x3 will affect here. x1, x2, x3 will also affect here. n11 and n12 will affect here. These two will affect here. These two guys will affect here. And these guys will affect here. And you understand that each node will bring in some amount of, I would say, noise. Because our neural system, when the neural system is damaged, lots of noise comes. You probably hallucinate. When the neural system is okay, then also some noise comes. So some noise, probability of some noise coming is still there. These noises are written as, let's say, D1, D2, D3, D for deviation, D4, and D5. And let's say that the activation function is simplistic, fx is equal to x. So whatever comes in goes away, no change. Okay, because if I do change, then the calculation will be much more tougher. So let's put the weight W1, W2, W3, W4, W5, W6, W7, W8, W9, W10, W11, W12. And I don't know what these W's are. So as Tarundeep asks, sir, how will I get these W's? Let's get these W's. So can you tell me what will be the input in N11 node? What will be the input in N11 node? This will be the input. Are you guys with me? what will be the output at N11 node? Same, because fx is equal to x, so whatever is the input, that goes out to be the output. Exactly, that becomes the output. Fair enough. What is the input of N22 node? And what is the output of N22 node? The same thing. As of now, if you have any question, ask me. What I forgot is, forgot is, okay, yes, N12 node, sorry, N12 node, not N22 node. Sorry, N12 node, yes. And I forgot this D1, D2, so that I also added. These are the intercept. You can say intercept, or you can say the noise. This is the noise or intercepts. Okay. Now let's talk about what is the input of N21. N21 is W7 and W9. W7 N11 and N12 plus D3, and output is also the same. And output of N2, sorry, input of input of N22 is basically W8 plus W10 plus D4, and output is also the same. Fair enough. As of now, do you have any query? Okay. And what is Y? Input of Y variable, the last one, and same is the output. Now, if I randomly put some values of W1 to W12, randomly, I will get some output of Y. I will get or not get. If I randomly put from W1 to W12 and from D1 to D5, if I randomly put some value, will I get Y0 or not? The output of Y. Can I calculate that? I will be able to calculate that. Let's say that y0 came up to be 0.7 and your actual y is that you got promoted 1. Then what is the error? Ya minus y0 square is the error, right? Now understand that what is your objective? You have got this y, you know already x1, x2, x3. These three things you know. These three things you know. The actual value of y you know. What you do not know is these values. What you do not know is these values. All these values. And what you did, that's why, is you randomly chosen some values. You have randomly chosen some values and got an error. After randomly choosing some values, you got an error. So then, now your objective is minimize this error because in your data set you have exact x values and y value, no? In the regression, what do you have? You have x values and y values? Same thing, no? It's a predictive model. So minimize this error by finding the optimal values of W1 to W12 and D1 to D5. So now I didn't get your question. So in a predictive model, anything that you try to predict, you have a y variable with you, no? Y actual is the y variable that is already there in your data set. And y0 or basically y predicted, y output is the one. No, why don't say all of these things? Why does correlation comes?
So for predictive modeling, you said now when y value is known. So that's why I just related to that.
So correlation is not prediction. That's a different story altogether.
Okay, sir. I was thinking in that aspect, sir. Okay, sir.
So in data set, when you do predictive modeling, you have, let's say, x1, x2, x3, y column, right?
Yes,
This
sir.
is how the data set looks. I am just suggesting, I'm just saying, Sonali, that is not y is equal to 1. I'm saying, let's say you got, after the calculation, let's say you got 0.7 and your actual is 1. That's a let's say. Okay, it's not 1. So after so much of the calculation, so much calculation that you have done, you get the y observed to be 0.7, sorry, y output to be 0.7, and y actual is 1, let's say, then there is some error. Now this 0.7 you got how? This 0.7 you got by randomly getting some values of W1 to W2 and D1 to D5. So you have to change these values in such a way so that this 0.7 comes closer to 1. Right with me? So minimize this error, minimize this distance. 0.7 and 1 are just example. In just next row, in the next row, it can be 0.5 and 0. In the next row, it can be 0.7, 0.77 and 1. These are all examples. These are not actual values. Okay, so you get some y0 and you get some ya. Y0 is your output, ya is your actual, and you get an error. Now you have to reduce this error by changing W1 to W12, D1 to D5. That is your job. Now, what is the method that we use in doing this? So we check, we do an algorithm called back propagation. We use an algorithm called back propagation. That means we try to optimize backwards. So this is the calculation that I have shown. The calculation starts from here and goes towards this direction, right? The calculation starts from here and goes towards this direction. This calculation method is called feed forward. This particular calculation method is called feed forward. That means every node is fed by the backward node. So x1, x2, x3 is feeding n11. x1, x2, x3 is feeding n12. n11 and n12 is feeding these two people. These two people are feeding y. So that's why it is called feed forward. Yes, for all the prediction cases, there will be always a difference between your observed and actual, and you want to try to find out how to reduce that distance in all prediction models, all. So Arun Babu has sent a private message. I am answering that. Okay, so feed forward, and when we optimize, we start from this side to this side, and that's why it is called back propagation. So what will I do? How will I optimize? I will optimize fast. Just check. What do I have to reduce? I will first optimize for W12, which is the closest to my Y0. What is my Y0? My Y0, if you remember, is W11 N21 plus W12 N22 plus D5. That is my Y0. So the closest weightage that I have to optimize is W12. So how to optimize that? So what I will do is I will run an iteration. I will run an iteration. So my change of W12, the idea is that the change in each iteration, I will change this W12. And that change will be proportional to its impact on the error. So this is the error, right? This is the error. So by changing the W12, if the error changes, then I will change W12. So the change in W12, let's say initially in the first iteration, when you did the feed forward, W12 was 1. And then you did all this calculation. Now you want to change, you want to optimize W12. So how will I optimize? I will change W12 to something else, and that change will be proportional to its impact on the error. So basically we follow this formula. Alpha into del E del W12 minus beta, where alpha is called learning rate and beta is called basically I would say a sticky factor. So beta does not let you change, and alpha says change, 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 change. And how you choose the value of alpha and beta will decide how fast it will learn. If alpha is very high and beta is very low, it will learn very fast, it will optimize very fast. But if alpha is very high and beta is very high and alpha is very low, then it will learn slowly. Understand this carefully. This is very crucial. That how does this learning happens? Generally, the learning happens using this kind of a formula. Let's say for anything, for any fx, I'm trying to optimize it over x. So this is x and this is y is equal to fx. And the curve is like this. I want to find out the minimum point. So what we do generally to find out the minimum point is, let's say if I start from here, I find out what is the value of y here. And then I change the x a little bit this side and a little bit this side. And see in which direction it is falling. So I see when I come to this direction, it is falling. So next I come here. Again I change a little bit in this direction. Next I come here. Again I change a little bit to this direction. Next I come here. Again I change little bit to this direction. Next I come here. And after that, if I further change, I will go up. If I further change, I will go up. So that's why I don't go up and I stick to this point. So that is how generally we do optimization. This method is called gradient descent method. Where we are basically in this particular slope, we are slowly moving downwards to find out the last point, the lowest point. Now by chance, if I give bigger jumps instead of small jumps for the same curve, if I give bigger jumps, what happens? Just notice what happens. The same curve, I start from here and I give a jump of this much. Then I reach here, so I got reduced. Then I give, means x-axis jump is this much. X-axis jump is this much is my x-axis jump. Next x-axis jump is this much. So I reach here, which is not the minima. You see, minima is at this point. Then the next x-axis jump is here. I come here. Next x-axis jump is here. So I come here. So here I'm making big jumps. And by making big jumps, I missed this minima point and I reached this minima point. So when you jump, all I'm trying to show you that if you try to learn fast, you will reach, Avinav, you will reach a local minima. Doesn't matter. So whatever be the case, you will reach a local minima. You will reach here and stop. That is what we try to do. How to solve that problem? I will tell you in a different class. But you will reach a local minima. But if you make bigger jumps, you will not even reach a local minima. So if you try to learn fast, and make bigger jumps, you might miss the minimum. If you make bigger jumps, you might miss the minimum. That is what I wanted to show you here. So exactly same thing applies here. If alpha is very big, then I will learn very fast, but I might be faulty. So alpha and beta basically balance each other. But whatever be the values of alpha and beta, majorly it is inbuilt. Generally we tweak when we become expert. Before we become expert, we don't tweak these values, whatever is inbuilt. But whatever be this value, ultimately it will depend on this thing. Ultimately it will depend on this thing. And let's talk about this thing and how to find out this. Because alpha and beta value, I have told you the concept, but these are inbuilt. But this is not inbuilt. This the algorithm calculates. So how to calculate this value? Let's talk about that. How much was the error? Error was y0 minus ya squared. This was my error. The point is minima, local minima. This is my error. So if I do del E del W12, will I get this? Just check. This is I will get this. Am I right or wrong? You will not get log. Ya is constant, so you will not get ya. What are you? So y0, yw1. How to calculate this? This is basically, if you remember, y0's function is so w11 into node 21 plus w12 into node 22 plus d5. That was y0. That was y0. It is inbuilt. It is inbuilt. So this value then comes up to be n22. Whatever is the score at n22, that is the value of here of this. So then the net point will be w12 will be 2 into e into, this is e, right? This is the error. So 2 into, sorry, this is square root of error, into n22. I can get this value from my calculations. I have already got this value from my calculations. I have already got this value from my calculation, so I can get this value from my calculation. That is the change that I will do in W12. So as I told, W12 will be alpha into delta E delta W12 minus beta. Alpha beta value are inbuilt until we become very advanced, like expert. We will not play with alpha beta, and this value I just derived to be this, and this can be calculated. Fair enough? So I know how much in the first iteration, how much I will change W12. and I will keep on changing that. W12 I will keep on changing until the change is not affecting the reduction of error anymore. I will keep on changing W12 until further changing of W12 is not changing anything in the error. Now for W12 it is easy. Just let us do it. I will do it for one more guy. Let us do it for W1. Let us do it for W1. I have did it for this one. This one was easy. Let us do it for W1 and understand what does that mean. W12 was easy. Let us do it for W1. So how much will be the change in W1? That will be alpha into del E del W1 minus beta. Right? How much is del E del W1? This is 2y0 minus ya del y0 del W1. Right? Right with me, just like W12, that up to this point the formula is same. Now, what is wy0 w del W1? Yes, alpha beta is same for every cases. Is right? I just broken y0. So here it becomes W11 into del M21 del W1 plus W12 into del N22 del W2 plus 0 because D5 is constant. Are you guys with me up to this point? There are lots of mathematics coming in. If it is very difficult for you, don't go into that. But it's my job to teach the mathematics also. Up to this point, are you with me? Did you get this derivation? Okay. Now, if I can derive this, I can also derive this.
Got it, sir. Got it.
0 Arun Babu, because D5 is constant. D5 is constant. Del D5, del W1 will be 0. Okay. If I derive any one of them, I can derive the other one. So for simplicity purpose, I will derive any one of them. What is N21? It is 1, 2, 3, 4, 5, 6, 7, and 9, if you remember. This is N21. So this same thing, W11 is the weightage, yes, that is independent of W1. All weights are independent of each other. So I can write this like this. So again the same thing. If I can derive any one of them, I can derive the other also. If I can derive any one of them, I can derive the other also. Let's, for simplicity purpose, derive any one of them. So I am making life simpler, but the guy actually does quite a hard job. Basically, for N12, there is no W1, so this will be 0. Right? W1 does not impact N12. W4, 5, 6 affects N12. Right? Just check the formula of N12. There is no W1. W4, W5, and W6 is there. But here it is W1 into X1, W2 into X2, W3 into X3. So this becomes basically X1 plus D1. So this becomes X1. So I will put X1 here. I calculated this. Similar way I will calculate this. Similar way I will calculate this. And once all this calculation happens, I will change my W1. That is for one single iteration. Millions of such iterations will go on and it will optimize. So the mathematics I have just shown, thankfully, we don't have to do the mathematics. Thankfully, the code will do it and find out the optimal values of W1, W2, W3, W4 to W12 and D1, D2, D3, D4, D5 and give you the result. The only choice that you have to make is how many layers you will put and how many nodes you will put in each layer, and that is a trial and error method. You have to try and find out which one is giving the lowest output. So I will save this calculation. Later point of time you can check the calculations. So what I will do is I will run an ANN. Now all this calculation, running of the code is one single line. Exactly one single line. So coding, there is nothing in the coding. Somebody was telling me that it's exactly 5 to 6 days job to learn the coding. There's nothing in the coding. And then it is just data cleaning. So probably 90% coding is cleaning the data and 10% is running the models. So I will open a data set called concrete.csv file. This is last day's data. Yesterday, I have given this data set. Could you find out that yesterday data set? So this data set has 1030 observations of 10 variables. The Y variable is the strength of the concrete, and these are all the X variables. So cement, slag, oftentimes the concrete strength you cannot know beforehand, because you exactly cannot know what is the quality of the cement, what is the quality of the raw materials that you are using. So you have to create a predictive model sometimes. When you try to create a big house or a big dam, you have to use this kind of predictive model. So 1030 samples were collected, their strength was measured, and their ingredients was also noted here. Now there is no functional formula how these ingredients will lead to strength, and we are trying to create a predictive model for that. So Y variable is my strength variable, and all other variables are X variables. So what will I do first? I will create a normalized function and then normalize the data. This is same procedure as we did in the last one. Then you can create a sampling, but I am taking the first 773 as training and rest as testing, but ideally you should sample it out. So for quickly doing it, I am not sampling it. So I have broken the data set into training and testing. 773 goes to training and the rest goes to testing. Okay. Then the library is neural net. Okay, so there is no library. I have to install this library. 1 minute, I will install it. Okay, in the meantime, can you who can share his this thing? Who can share his screen? Anybody can share his screen who has neural net already installed? Okay, Bindu, I'm giving you the presenter right. Can you share your screen? Bindu, can you share your screen? Okay, Bindu. So where are we? Can you run the library neural net line number 13? Okay, now run 15 to 18. Select 15 to 18 together and run it. So it ran. Now just plot line number 19. Go to the plots, zoom it up. Zoom. There is a zoom sign. Yeah. See the blue ones. Everybody see these blue lines are the estimate of D1 and D2. The 2 Ds. So when I say nothing, it says that when I say nothing, it notes that there is only one hidden layer. So default is one hidden layer, one node. So all the weightages are given. The blue ones are the D weightages, basically the errors, the intercepts, and it is giving me that it converged in 1589 steps, and currently the error is getting us mean error is 5.66. Now our job is to improve this. Can you close it? So in the next one, I will try to compute on the test data. So instead of predict, here we use compute function. So line number 21, please run. And then run line number 23 and 24. So I'm just checking the RMAC. That see line number 24 is RMAC. The error, they have taken the mean of that and then they have taken the square root of that. So the RMAC score is coming 0.11. The RMAC score. Now our job is to find out another model where this RMAC score can be improved. That means RMAC score can be reduced. So can you scroll down? So in the next one, you see the only thing that changed is hidden is equal to 3,2. That hidden is equal to 3,2 was not written before. So because it was not written before, that particular part was default 1. Now I have brought 3,2. What is 3,2? It was in the last day's files, Sonali. Just check 7june.zip file I have sent yesterday. So what is 3,2? 3,2 means there are 2 layers are there. Can you hear me? Hello? Others, can you hear me?
Yes, sir.
Yeah, okay. Okay, so there are 2 layers. The first layer will have 3 nodes. 3,2 means that there are 2 layers. The first layer has 3 nodes and the second layer has 2 nodes. That is the nomenclature's meaning. 3,2, the meaning of that is the first layer has, there are 2 layers are there. First has 3 nodes. Now why did I choose 3,2? No reason. You have to try and test. So why don't you select line number 27 to 30? run it. So it will take some time because lots of W's has to be estimated. It will take a little bit more time than the before. Yes. Now plot it. Can you hear me, Tarundeep? Yeah. So see, this is the new plot, which is very cumbersome. There is very cumbersome, but I don't care. I don't care about the weightages because these weightages are randomly found out through an optimization. I will run once more in some other computer. These weightages will change. So I don't care about these weightages. What I care about is the RMSE score. So let's find out the RMSE score. Yeah. Close it. Yes. And yeah. Now run this 34 to 36. So compute function, and then we measure the RMSE. Root means square error. And root means square error has increased 0.1468. Previously it was 0.1133. So this hidden layer model is not giving the better result. See, Sanindos's was 112 because his computer and this computer is different. Now all I'm trying to say is that now what you have to do, you have used 3.2 and it is giving higher RMSE. What will I do? I will change that hidden layer. Now what I will change, I don't know. So ideally what I generally do, or what is the best practice in this context, is run a loop. Like previously I ran a loop for k is equal to 1 to 13, if you remember. Here I will run a loop for k is equal to 1 to 3, because up to 3 nodes in each layer and up to 3 layers, that is the maximum. So that is what we will try and find out which one is giving best result. So I'm not showing that code. You should code, that's a loop code. You should run it on your own. But we generally run it and find out what is the best result. So that's how the ANN, the artificial neural network works. Now, whatever that KNN algorithm can do, whatever logistic regression and normal regression can do, ANN can do everything. ANN can be applied both if your Y is categorical or it is continuous. If your Y is categorical, convert them to dummy variables. If your Y is continuous, like here it is continuous strength, then you have no problem. So code wise, it is just one single line, as you see, line number 27. It is just one single line code wise, but it does all these calculations in the background that are shown in the PDF file. So that's all for today from me. I will be opening for questions right now for these two topics. These two are heavy topics, both are heavy. Probably this week has been pretty heavy because text mining was heavy and this is also heavy. So I will strongly suggest that you go back and listen to the video once more to understand what it is there.
Okay, sir.
Yes, sir.
So hidden argument Vipin, hidden 3,2 means the first layer will have 3 nodes and the second layer will have 2 nodes. So 3,2, Arun Baba, I'm taking the present, Bindu, I'm taking the presenting right. 3 comma 2 means something like this. Let's say x1 to x11, whatever, all those x's. Then first layer, there will be two layers. First layer will have two nodes, three nodes, sorry, in 1, 3. And second layer will have two nodes. 3 comma 2 comma 3 means third layer has another 3 nodes. Comma 2 means fourth layer has another 2 nodes. Okay. Understood? Okay. So activation function by default. See, just imagine, Preeti, good that you have asked this question. Just imagine here, for simplicity's sake, I have taken activation function to be fx is equal to ax. Here, the activation function was fx is equal to ax. By chance, if it was fx is equal to this, could you do this in hand? Can you just do del x of e to the power x by 1 plus e to the power x? And then basically del x of e to the power x by 1 plus e to the power x by 1 plus e to the power x by 1 plus e to the power x. That kind of complexity would have brought in if the activation function is, and that is common. That kind of complexity comes up. No issues in that. But we, in our hand, we cannot do that. So how to choose the activation functions? The default is logistic function. The default in most of these things are logistic function. And if you want to change that, so by default, the activation function is basically the logistic function. That means activation function is fx is this. But if you want to change that, check the neural net help. Okay. If you want to change that, check the neural net help. Generally, we don't change. Generally, all these default things we generally don't change. But when you become a data scientist handy with all of these things, you will change alpha. The learning rate, I told you, alpha, beta, that also you will find out if you put this question mark neural net. No, you cannot deduce that. Pritham, you can, there is no meaning of those weightages. It's just that it has reached a local minima there. There's a difference between local minima and global minima, right? You are an engineer, you should be able to know. So let's say this is an fx. If I start from here, I will reach here. That's the local minima for me. If I start from here, I will reach here. But when I reach here and stop, I don't even know that whether there is a global minima or not. So even if I get a W1 to be negative, I don't know exactly that whether it is actually negative or not. Okay, thank you guys. I will see you in the next week.
Where you have left?